This is our first lab of the semester, and it deals with the first surprising fact that we're dealing with this semester. First surprising fact, and that is that gravity does not make heavier objects fall faster. Well, how does that make sense with what we're used to? I mean, we all know that if you take a rock and a piece of paper and drop them off the top of a roof, the rock will hit the ground first. But when you have that effect, it's not because gravity makes them fall differently. It's just the effect of air resistance is different on different objects as they fall. And we saw that in that video where a bowling ball and a feather were dropped from the top of a vacuum chamber before they pulled the air out. You saw what you are used to seeing, that the bowling ball falls right down and the feather flutters down slowly. But once all the air is removed and there's no air resistance, they fall the same. And so our experiment today it's a simulation really, and we're going to use a spreadsheet to do calculations. But the effect is this. Imagine that we have a bunch of different spherical objects, a bunch of different balls. We have a few that are the size of tennis balls, and they're made out of different materials. One is lead, one is aluminum, one is cork. And we drop those from 1 meter in the air, about a little over 3 feet. And then we drop them all from 20 meters in the air, a little over 60 feet. And we see how long it takes for them to hit the ground and compare that to how long it would take if there was no air resistance. So we're going to drop balls from heights of 1 meter and 20 meters. And the balls are going to be tennis ball sized, lead. There'll be a few other that are tennis ball sized, and then we'll have beach ball sized. And basically, we're just going to try to see how air resistance affects these different size and different density objects. And I'm going to want you to make predictions before we do this sort of virtual simulated dropping of these objects. For example, a small lead ball, you probably would expect air resistance not to change its motion very much at all. A large ball made out of cork, you would expect air resistance to have a much bigger effect on its motion, and that's the kind of prediction I want you to make. Now, as far as doing the actual calculations, here is the spreadsheet we're going to use. And you don't have to know anything about these first 3 columns. Those are just the things that define the different shapes and different densities, and I'll tell you what numbers to put in to represent the different things. The 2 PY columns are the positions of the object at different times, the time that's given at a single. So, the 0.008 seconds under time here corresponds, the way I have it set up, to a height of negative 0.00027 meters. Okay, these are all in SI units. And so to make something drop 20 meters, I think the entries I have in the first 3 columns all represent the lead tennis ball sized object. We'll put a 20 in here for the starting height. So at 0 time, we'll have a height of 20 meters. Now, we would expect a tennis ball size lead object to fall pretty similarly to the way it would fall without air resistance. It's so dense and not a very big surface area. And so now I'm going to scroll down to see how long it would take to hit the ground without air resistance. I'm going to scroll down until the no air resistance column goes from a positive height to a negative height, and then I'm going to look at what time that is. So keep scrolling down, and there it is. I found the time, and I'm going to say the last instant before it hit the ground. That's what I'm going to use. Happened at 2.019 seconds. Okay, so if you drop a lead tennis ball sized object from a little over 60 feet in the air, and there's no air resistance, it would take 2.019 seconds. Well, that's actually, if you're talking about no air resistance, that's going to be the same for any objects, because we saw that with no air resistance, all objects fall the same. And now what if there is air resistance? We don't expect a big difference, and we can see it's not that big a difference, but it did fall 20 meters, so it was going pretty fast. And in this case, the lead ball hits the ground at 2.023 seconds. So less than 1/100th of a second difference, but there is a difference if you look at thousandths of a second. And so that's what you're going to do just over and over again, and you're going to follow the instructions in the lab manual. The lab manual is going to say what number to enter here, here, and here. It's going to tell you what height to put in for time equals 0, and then you're just going to scroll down and find out how much for that object of a difference air resistance made compared to no air resistance. Okay, well, let me know if you have any questions. Email me, or we can set up Zoom talks, and I'll talk to you soon.